Alright, so today we're going to be talking about elastic and inelastic collisions. A collision is a linear momentum conserved, equaling mass times velocity equals mass 2 times velocity 2. Elastic collisions are the objects involved remain separate, so when they come to each other, they bounce off. Example of this would be like a soccer ball or billiards, a pool. With the elastic collision, total kinetic energy and momentum is conserved. The equation for elastic collision would be the mass times velocity initial plus mass 2 velocity 2 initial equals mass times velocity final plus mass 2 velocity 2 final. When you convert into kinetic energy, you then have your 1/2 mass 1 initial squared plus 1/2 mass 2 velocity 2 initial squared equals the equation final.
Alright guys, so we're about to talk about inelastic collision. So inelastic collision is basically the opposite of elastic collision. When two objects collide, they stick together and continue going one direction. The equation for this is m1v1 plus m2v2 is equal to m1 plus m2 times velocity final. With inelastic collision, the total momentum is conserved, plus kinetic energy is not conserved. An example of this would be like an 18-wheeler having a wreck with a car, and like they both just sticking together and just continue going the way of the 18-wheeler. That's basically an example.
Okay, so we're going to talk about inelastic equations. So this is an example, basically showing the equation that's worked out. So this example would be if an object has a certain mass and velocity going towards another object, and instead of them bouncing off, they go together in a direction with their combined masses and velocities. So first, you got to work out the ratio of kinetic energies before and after the inelastic equation. So first, you got to figure out this right here, that the energy total right here, so you can transfer it over. So you get the kinetic energy of the final and the initial kinetic energy, divide those, and you get 1/2 times m1 plus m2, so the masses of the first one times the masses of the second one, times m1 divided by m1 plus m2 v1. So now you're taking the mass of the initial, divide that by the total mass times the velocity and square that. That'll give you the kinetic energy of the final force. So, and then to find the initial, you take 1/2 m1 times v1 squared, and that's just like a equation for kinetic energy. And then you end up with, that should equal to m1 over m1 plus m2. And that'll give you basically the ratio of energy before and after inelastic. After that, you gotta look at the fraction of kinetic energy. So to get that, you just take the initial kinetic energy, subtract that by the final kinetic energy over the initial kinetic energy. And then the main things that you'll use for this, like we were talking about the equation here, you're looking at momentum, m1v1, like what we're talking about right here. Kinetic energy, 1/2 m1 v1 squared, this equation right here. And then conservation of momentum, that's the equation that we use right here. So you put all those together, put it in this equation, and type your numbers in, and that'll give you the final numbers for that.
So we're doing elastic collision now, and right here's an example. We got a cue ball, like say like you playing pool, and then it hits the other balls, and then you just separate or something like that. That's pretty good. And so now we go down to the relationships, and we start with the first one, conservation of momentum. And to find m1 times v1, it's just m1 times v1 plus m2 times v2. And the second one, conservation of kinetic energy, 1/2 m1 times v1 squared, it equals 1/2 of m1 times v1 squared plus 1/2 of m2 times v2 squared. And the third one for head-on collisions, to find v1, we just do the mass of 1 minus m2 divided by the mass of 1 plus m2 times v1. And for v2, we just do mass 2 times the mass divided by m1 plus m2 times v1. And the fourth relationship is the velocity for head-on collisions is equal to the velocity of separation. And this equation right here can apply to elastic collisions since we can always choose a reference frame riding with M2 before the collision.
Delta K, which is K final minus K initial. And the K equals 1/2 mass times velocity squared. And so now we're going to plug it into the equation. And mass final equals mass 1 plus mass 2 because the mass 1 and mass 2 combine together at the end. So now we're going to plug in our given into the equation. So it's going to be 1/2 80 kilograms plus 40 kilograms, 4 meters per second squared, minus 80 kilograms times 6 meters per second squared. And our final answer for delta K is negative 480 joules.
Hey, so today we're going to be talking about inelastic collisions. Now, our group did this example for inelastic equations where one group member runs into another group member and then their combined force and velocity takes them into whatever direction they were going in. So our known factors would be the mass of both people, the velocity, because we can see how long it takes them to get from one point to another, and then we finally see how fast he moves into that direction. So, to find some knowns, we go to our timeline right here. So when he starts moving, he's at 8 seconds. So he starts moving, and then if we pause it right when he hits, we can see it's at 10 seconds. So taking that into account, we know that this area right here, because we measured it, is 10 meters. And then the time it took him to get to that area was 2 seconds. So divided by 2 seconds. So take that, we get 5 meters per second. Now we know that he weighs 100 kilograms, which is 220 pounds, and he weighs 70 kilograms, so about 160. So we can start writing our velocities. We know that if he's moving at 5 meters per second, since he didn't move, he's moving at 0 meters per second. So let's write all our knowns. So we have M1, which equals 100 kilograms. We have V1, which equals 5 meters per second. We have M2, which is 70 kilograms. And we have V2, which is 0 meters per second. So what we're trying to find is the final velocity in that direction. So the equation we can use for this one will be, so general equation would be M1, let me write down here, M1 V1 plus M2 V2 equals M1 V1 plus M2 V2. Now to find the final velocity, we take M1.
So in conclusion, I kind of put the one of our other attempts. I didn't have time to put this in the video, or enough time in the video to put it in. But basically, in conclusion, we went over inelastic and elastic equations, showed the difference between the two, what they each meant, derived them, and then showed some solutions for them, and then demonstrated an example. So that'll be it for our video.